Hello, I'm Simon Arnold, President of Innovative Global Solutions. Here at IGS, we focus on creating low-cost, low-power solutions for problems afflicting marginalized populations across the globe. Our student-driven teams strive to combine a range of engineering disciplines to positively affect the health of those in need. We currently have 3 different teams operating simultaneously to complete progress on 3 different projects. Some of you may be familiar with our infant incubator team, which is working on creating a simple and budget-friendly system to help reduce infant mortality in sub-Saharan Africa. Our newest team, working on the emergency respiratory filtration system, is working on a portable device that will filter ambient air for a wide range of medical and emergency applications. Finally, we have the medical tent environmental control team, whose progress will be the topic of this presentation. Enjoy.
I'm Ella Merklein, the team lead for medical tent environmental controls. Our team is developing a product that can be used in temporary emergency shelters to make medical tents more comfortable and efficient for healthcare workers and patients. This semester, we are building our first prototype, turning our ideas into a real working design after our initial semesters that focused mainly on the proof of concept and testing. Since the beginning of the project, our focuses were on improvements in the thermal, lighting, and acoustic environment inside the medical tents. This inspired us to design a curtain with heat-exchanging properties, lighting influence, and sound-dampening materials to create a better space for medical care. To do this, we divided into 3 teams: the hot mechanical, which is focused on heating; the cold mechanical, which is focused on cooling; and electrical, which is focused on the controls and user interface, which will be introduced next.
Hello everyone, I'm Rachel Andrus, the electrical team lead on MTEC. The electrical team members consist of Ellen Merklein and Maggie Norberg. Over the past 3 semesters, the electrical team's main focus has been the user interface and sensor integration for the prototype. At the start, we had humble beginnings of a simple microcontroller hooked up to a temperature sensor, and we were excited when we figured out how to gain readings from the sensor and plot them. Last semester, our team was able to research different temperature sensors, LCD touchscreens, relay modules, humidity, and water level sensors for the device. For our current prototype development, the touchscreen and temperature sensors were the main focus. For the user interface development, we first decided on a wiring configuration and ran program libraries to test the graphics and touchscreen functionalities. This way we could confirm that the screen was operational before coding began. After that, touchscreen user interface development took off. We started with a home screen and a few buttons. Then cold and hot screens were added, and soon we reached the point where the user interface is today. The user interface features a home screen displaying the current room temperature in either Fahrenheit or Celsius, a settings screen to choose the units which that display works in, a toggleable temperature to define system functions, a cold and hot screen that allows the user to access basic information about the cooling and heating systems, an air screen where the user can check if there are any issues with the device, and basic rules. So, for example, the user can't have the heating and cooling systems running at the same time. While coding for the screen was happening, other members have investigated the relay as an option to control power allocation to the different elements on our physical prototype from the Arduino board. There were some struggles with the relay requiring high current draw and the wire configuration of our circuits to avoid shorting other elements. However, development with the relay has continued nicely and will eventually be integrated to the prototype. In the future, this team will continue to work on power allocation for the prototype, developing the user interface, integrating other sensor components, and working with our mechanical team.
Hello and welcome to Hot Mechanical. My name is Karen Orneval and I'm part of the sub-team that is responsible for investigating and producing a unit that creates heat in the medical tent environment control device. In spring 2025, our members consist of Holly Flores, Olivia Capelli, and myself. Initial work began with a proof of concept. The construction of this device helped establish an understanding of the way that the heating and cooling systems function and interact. From there, another device was built. The mini curtain was a scalable build that was meant to help understand and identify the physical characteristics of what a 2-scale prototype would feature. The mini curtain provided data such as mass and volumetric flow rates, heat transfer area, piping material requirements, heat distribution mapping, and power requirements. This data was scaled up to assist with material purchases for the prototype. Finally, the prototype, amicably named Proto-Wan Kenobi, was built in February of 2025. The prototype does meet the design criteria for heating and cooling without obstructing access to the patient. Currently, the team is testing a preliminary arrangement of coils and wiring to achieve efficient heating by reducing power consumption.
Hi, my name is Matthew Kassab. I'm the mechanical team lead. I'm currently part of the cold mechanical team on the MTEC project, focusing on the cooling system integrated into our device to cool the enclosed space that houses the patient. The cold team currently consists of Simon Arnold, who you heard from previously, and myself. This prototype in its current state is the product of a few semesters worth of work. Our previous proof of concept was comprised of an acrylic box with a loop of vinyl tubing contained inside, designed to mimic an enclosed patient space within a tent. We performed quite a bit of testing using this model, and throughout the course of that, we reached the conclusions that we needed to improve our tubing from the vinyl hose that was being used at the time, as well as our cooling system. The Peltier device at that time had been repurposed from a mini fridge used to keep cosmetics and drinks cool, leading to testing with a new water cooling Peltier device and a loop of copper tubing. After verifying the effectiveness of this system, we then scaled this up into a full-size prototype. Currently, the heart of our cooling system is a 180-watt Peltier device that directly cools the water, which is then pumped through the system with an aquarium pump. This Peltier device is designed specifically to cool down fluids, making it pretty perfect for the application we need. The aquarium pump sits within the water reservoir, pumping water directly into the Peltier device, at which point it is sent into the curtain, where the copper sections running vertically throughout can then distribute the cold into that copper and disperse that into the...
In the upcoming semesters, our team will be working to test this prototype and make improvements with the materials and functionality in order to come up with a more polished prototype. This will include added features beyond just the heating, cooling, and control elements. Thank you to Plexus for funding and giving professional advice, and to Dr. Manser for project direction.
Thank you for your time. Innovative Global Solutions is an interdisciplinary enterprise with 3 different teams that all work on individual projects. If you're interested in our other projects, check out our infant incubator team. All 3 teams have made exceptional progress this semester and are looking forward to continuing this hard work through the future semesters.